What's going on, guys? I want to take this opportunity to give you guys a little refresher. We did just have a small little incident with the chiller system, so I'm in front of the computer and figure that I'd shoot a quick video um, as a refresher, as I said. So, the other videos kind of probably went too in depth. I know I do that from time to time, so it's always good just to try and boil this down into the simplest terms possible. So that's what I'm going to attempt to do here. I'm sorry if I didn't. Always call me if you need anything or have questions on the system. So the three things in the simplest terms that describe how this system works is pumps or flow through the system, the minimum flow over the chillers by themselves, and the temperature of the supply water. So boiling this entire complex system down into those three things, and then what actually controls those three things, those three variables, and how we accomplish meeting those criteria. So the first one is the pumps and moving water through the system. So water has to be moving through the system, obviously, to remove the heat from the data center. So formerly we had one pump per chiller, and they were just flowing 100% all the time, which is not energy efficient at all. So that's why we changed it to a variable primary system. As explained in the last videos, basically a variable primary system is the primary pumping of the system, and we can vary the speed of which, vary the flow in which that it operates. So that's variable primary system. So how do we know how much water we need to flow through the system? So we've just determined that we know that this system needs to flow with a pressure differential of 5 psi. That is here. That's where we tell the system. We just know it needs to run at 5 psi through an engineered solution. We actually know how much water we need through an engineered solution. So, why that's important is, these sensors are down here, and that is what dictates the pump speed, how much pressure and how much water we're flowing through the system. So if we just watch this closely for a second, we've already talked about our set point is 5. So as we go above 5, as you can expect, the pump speed is probably going to go down. We just watched it go from 53 to 52. Now 55 because it's under 5. Now it's overshooting 5. It's going back to 6. Actually, it operates off 2 sensors. And I was going to explain that later, but actually it's more important now. So, there's 2 sensors in the system for redundancy. It's going to choose the lesser value. So now that this one's higher, we're going to work off this one. Normally it's loop 1 that's always lower. Sometimes it's loop 2, so you just got to kind of pay attention to that. So again, the software chooses the lesser of the 2 to operate off of. So now it's 5.8. We're probably going to start seeing this thing back off. Yep, 56.5, now 55. 55.3 because we undershot it a little bit. Now it's going to go back up, 58. And we overshot it again, so it's going to dial back down. But I hope you get the point. So literally the only thing that controls the pump speed is these 2 differential pressure sensors. So these sensors' jobs are only to control the pump speed, and the byproduct of that is the amount of water that's flowing through the system as a whole. So if you watch it, again, the lower the differential pressure, the higher the pump speed. We just watched it happen again. And there it goes. And then conversely, the higher the differential pressure, the lower the pump speed. Now, The second thing that we care about is maintaining the minimum flow over the chiller. So the problem with varying the flow in the entire system is potentially we could get into a scenario where we're not flowing enough water over the chillers themselves. So the manufacturers actually dictate how much flow over the chiller there needs to be before it shuts off and it goes into alarm. So early on when we were designing the system, we put the set point, which is right here, at 500 because that's what the manual said. 500 is the minimum flow for the chillers. The problem with that is, as you can see, since this is varying so much, these flows, these GPMs are all over the place. So when we set it at 500, it could be anywhere from 420 all the way to 600 something. And when it got down to 420 for a long enough time, it would actually sense, hey, this chiller says I don't have any flow anymore, go into alarm and shut off, and it would actually shut off. So through some just tuning and fiddling with the system, we chose 550 as that point where it quit going into alarm, but it's still close enough that we're not wasting a bunch of energy by flowing too much water. So that was the happy medium there, and that's why we chose 550. So what accomplishes this 550? We know the pumps are pumping water through the system, but it doesn't care about the chiller flow. It only cares about the differential pressure. Well, that's where the bypass valve comes in. So this is literally bypassing water from the supply to the return. As you can see here, it's installed up on the roof, up against the guard railing. If you want to go take a look at it at some point, but that's where that is. So its sole mission in the system is to maintain this 550 set point. So as we watch it, the pumps are varying in speed, which is why these flows are going all over the place. But we can see that it's a little bit low, so the bypass valve is going to be relatively static. But as those flows start increasing, this bypass valve closes. We just saw it happen here, just a little bit. So this is 590, we're at 37.6, 35.5, and then we undershot, so then it's going back up. It's going to start climbing. Boom, right there. It's probably going to keep climbing. 45, 46. It's trying to maintain 550 right here. So again, in the simplest terms, the only thing this bypass valve controls is the minimum flow over the chiller. Now, the third thing that we care about is the chiller supply temperature, the supply water temperature, also referred to as the leaving water temperature. I prefer supply. It's a little bit less confusing. So, the system is set to 46 degrees set point. So these chillers are trying to get water down to 46 degrees. It'll overshoot it a little bit, but within reason, it gets down to 46. Why do we care about 46? Where do we get that number? So the 46 is, again, a manufacturer specified temperature, but it's actually of the Cray units downstairs. So the Cray units have to have 46 degree water to remove the amount of heat that it's rated for. And you know that by looking in the manual, and it says, okay, this Cray unit will remove, 30 tons of cooling, but it'll be at 72 degrees return temperature, 50% relative humidity at 46 degree water temps. So that's where we get that 46. Those Crays have to have 46 degree water to remove the amount of energy that they're rated for. And of course, there's an entire chart which we won't get into, but that's where we get that 46 number. And that's all that these chillers care about, is maintaining that supply water temperature. That's it. And that's all the chillers are looking at, is to maintain this. And as long as it has minimum flow and all the compressors are working well, this unit is going to give off that temperature. Why that's important as well. So the system actually looks at the supply temperature to base how many units are running. So not to confuse that with this next thing I'm going to talk about, which is the minimum chiller call. So we tell it, the system, hey, you have to run 2 units to maintain redundancy, because that's just what we do. We run 2 units just in case one fails, the other one doesn't. It takes a long time for them to stage up and run. Therefore, we need to have 2. That way, it just takes the load and is a lot faster, and our temps don't get crazy. So we talked about the minimum. Now we can talk about how the system looks at the supply temp and regulates the system there. So it's looking at this sensor right here, and ultimately when it gets installed sometime in the future, this supply temperature right here. But for now, it's just this one. It's the only one you care about. It looks at this number and says, hey, how far am I away from 46? I'm pretty close, so the minimum number of chillers is probably going to be fine. And that's all it looks at. That's all it looks at is right here, this number. Earlier, when chiller C had an issue and it had to fire up B, the time it takes for B to fire up, it actually got up to 51, and then got as high as like 53 degrees supply temp. And once we cleared the alarms on C and it was healthy again, the system said, good, I'm so far away from set point, I need some help. It turned on a third chiller, and all 3 were running to get this number back down closer to 46. And once that number got close to 46, it kicked this unit off automatically. So this supply temperature controls how many chillers are running, with the exception of the minimum chiller call. If I tell this system to run at 1, if I tell it to 1 and say okay, in a few minutes this will actually shut off. And then as this approaches 90% or so, and it can't maintain 46 anymore, it's going to call for B. It's going to call it on. And then if it can't maintain set point, it's going to call for 3 and then 4 to get this number back down. So again, hopefully this makes a little bit more sense. It's a little bit more basic. I'm not explaining, probably as in depth as before. So in summary, again, the 3 things that we care about is flow, minimum chiller flow, or system flow, minimum chiller flow, and the temperature, or the supply temperature, and then in which controls those. So what controls the flow through the entire system is this differential set point. As the sensor reads lower, the pumps are going to kick on higher. As they read higher, its pump speed's going to go back down. That's its sole mission. Then that's the total flow through the system. And then to maintain minimum flow over the system is where this bypass valve comes in. And as we've already talked about, as this chiller flow increases, this will actually decrease, and then obviously the converse will happen too. And then the last thing is the set point, the temperature set point, the supply water set point. And all it's caring about is getting to 46 and staying at 46, and this is the sensor that it uses to do that. As this temperature increases, more chillers will run, or these will stage up. But as this one gets higher, it's going to potentially call for a third. As it gets lower, it's going to go back down to its minimum chiller call. So again, hope this is helpful. As always, give me a ring, shoot me an email if we need further explanation or anything. But until then, we'll talk to you later.